This video will discuss additional details about ANOVA and statistical power. So for ANOVA or any statistical test, you have these four pieces that work together to come together to give you a statistical conclusion. And these four have to be in balance and work together so that you have confidence in the statistical conclusion. So you have the sample size, which is the number of cases or units or people or participants that you have within your data set. Your effect size is really about practical significance, and the thinking about even if you have statistical significance, is your result practical in the sense of the outcome units make sense. So is there enough of a change with the outcome units to make it a practical action item? And then you have your alpha level or your significance level, which you set prior to running your statistical analyses. And we tend to use 0.05, but you could also use 0.01 or 0.001. And this is that number that you compare your p-value to identify statistical significance. And then we have the power. And the power are how likely or what is the probability that you will see an effect, and a statistically significant effect. And power is related to confidence intervals and how likely you are to see a result that is statistically significant for the majority of your distribution or your sample. So power is this probability of getting significant results. So being able to reject your null hypothesis. And power is in this relationship with effect size, type 1 error or alpha rate, and your sample size. And with ANOVA, it's really about the number of groups as well as the overall sample size and the error variance associated with that ANOVA. But every statistical analysis uses power, and power is a number that runs from 0 to 1 because it is a probability. So it's 0% likely all the way to 100% likely. And usually you want your power for any of the analyses that you do to be anywhere between 0.7 and 0.9. And it really depends on your study design, but also it depends on your research and your context, and also on your industry. So if you're trying to get federal grants, you usually want a power that's upward of zero point 0.9, and you account for a zero point 0.9 power with the sample size that you would be using. Now, also, you would change the amount of power that you are calculating and expecting with your statistical results based on the potential impact of the results. So you want to have a higher power for federal grants because you want to be able to guarantee or closely guarantee that you would be getting significant results in the work that is being funded. But also, if you have some high impact decisions that are being made based off of the results, so if it's like something for admissions, or what schools are closed and which aren't, or who gets hired and who does not, or who gets into a particular program and who doesn't. So those would be considered high impact actions based off of the results, then you want to have a higher power to make sure that you can be very confident in the results you're receiving and in the results that you're basing those high impact actions on. So there are some general things that impact power that you have to think about when you're designing your research, and especially in thinking about research that is going to be using an ANOVA as its base analysis for answering the research question. So the design of the study um, and the design of your study is going to include your sampling. So, are you getting an ample sample size? And from who? Is it the right data from the right people? Also, what your factors are. So, these are your independent variables, but remember, these are also in ANOVA, these are your grouping variables. So, your power could be impacted by how many groups that you have as well as who those groups are. Um, then it's pretty standard of like what statistical test are you using, what is your alpha level, so your level of type 1 data, and also your significance level. The directionality of your significance test, where if you are you only looking for positive results, are you looking only for one group to absolutely be higher than another group? Those can change what your power needs to be. And also this magnitude of the effect on the population. This is those high impact decisions, and making sure that if it's a high impact decision that is being made based off of those results, or high impact actions that are being taken based off of those results, that your power represents that and reflects that this is a high impact set of results or decisions that are being made based off of the results. So this graph just gives you some context on looking at power, effect size, and sample size together and how they impact each other. So if you have, as your let's see, get a color here. As your sample size is increasing and your power is increasing, each of these lines is effect size. So what's happening with effect size? So this just kind of gives you a visual of the relationship between these different parts and pieces of power.